So here is another question on simple harmonic motion. So it is given that the vertical motion of a huge piston in a machine is approximately simple harmonic type, and it has a frequency of 0.5 second inverse or 0.5 hertz. A block of 10 kg is placed on the piston. What is the maximum amplitude of the piston's simple harmonic motion for the block and the piston to remain together? So let us try to visualize this whole situation. So it is given that the motion of a piston in a machine is simple harmonic type, which means it is moving to and fro, up and down like this, or sidewise maybe towards the left and right like that. No, I think it's up and down, yes, because the block is placed on it. So yes, up and down motion, okay, not sidewise, otherwise the block cannot be placed on it, okay. So it is up and down motion in between two extreme points. Then another thing which is given is that a block of a certain mass, it is placed on it, okay. So here 10 kg block, yes, a 10 kg block is placed on it. So we have to determine the maximum displacement from the mean position to the extreme point. The maximum displacement, that value we have to calculate so that the block and the piston, they remain together, they remain intact, in contact with each other throughout the whole motion. Now here one thing which we have to remember is that gravity will act downwards here, and here the acceleration of the SHM motion, that will come into play. Now we know that for a standard SHM equation of the form A sine omega t plus phi, the velocity, okay, that is given by dy by dt, which is equal to a omega cos omega t, okay, and acceleration is given by dv by dt, or second order derivative of displacement equation, which is equal to minus omega square a sine omega t. Here the maximum velocity, that is equal to omega a, and the maximum acceleration magnitude wise, it is omega square a. So here the condition for the block of mass 10 kg and the piston moving with SHM motion to remain intact is that this acceleration, the maximum value of SHM acceleration, it should always be lesser than or at most equal to acceleration due to gravity. It should not exceed the g value. If it exceeds g value, then the block and the piston, they will lose contact, okay, the block will fall off, or it will fall from the piston. So that is the condition, a max is lesser than or equal to g. So that is the condition. So here the frequency is given, okay, the frequency 0.5 second inverse, that is given. So here if we put the value here, it means omega square a, it should be, we'll put the equality condition, that is equal to g, that, okay, because it can be either lesser than or equal to g. So omega is equal to 2 pi f, we know that, 2 pi f. So here we'll substitute the value, that implies omega is equal to 2 pi and the frequency is equal to 0.5 second inverse. It is given 0.5 second inverse. So 2 pi into 0.5 whole square into the amplitude of SHM is equal to 9.8 acceleration due to gravity meter per second square. That implies A is equal to 9.8 by 2 pi into 0.5 whole square. Here we are using this equality condition. It should be either equal to this or lesser than that. Similarly, here A is the maximum displacement, okay? It can be lesser than this value, okay, lesser than this value, but it should not exceed it. So here the maximum value of the amplitude, that is equal to this coming, if we calculate 9.8 by 23.140, when we are putting the values, it is coming around 0.99 meters. So it is the maximum value of the amplitude of SHM. It should not exceed that. It should not exceed this value. It should always be lesser than this. Okay, so this is the thing. Okay, so this is the maximum value of the amplitude for this SHM motion for the block and the piston to remain in contact. If the amplitude value goes higher than 0.99, the block will get separated. If it remains below it or equal to this value, then they will remain in contact. Okay, so this is the thing. A very good question which involved a concept of mechanics too here. So yes, a very good question. So here is another question on simple harmonic motion. It is given that a particle is executing SHM along a straight line when the distance of the particle from the mean position has values x1 and x2. Okay, distance from the mean position, they have values x1 and x2. The corresponding values of velocities are u1 and u2 respectively. Show that the time period of oscillation is given by t is equal to 2 pi whole into x2 square minus x1 square by u1 square minus u2 square root over. To the power 1 by 2 means root over. Okay. So here for this SHM equation, y is equal to a sine omega t, considering initial phase angle or not, for this standard SHM equation, here the data is given relating position of the particle from the mean position, that is y, and velocity. So we have a relation which which is in terms of these two parameters, that is velocity v is equal to omega angular frequency into a square minus y square, where a is the maximum displacement from the mean position or amplitude. So here it is given that for y is equal to x1, velocity is equal to u1, for y is equal to x2, velocity is equal to u2. Okay, so here v square will be equal to omega square into a square minus y square. So putting these values, for y is equal to x1, velocity will be u1 square is equal to omega square into a square minus x1 square. Okay, that is equation number 1. And for y is equal to x2, v is equal to u2, that implies u2 square is equal to omega square minus a square minus x2 square. Equation number 2. Now, subtracting these two equations, we get u1 square minus u2 square is equal to omega square into a square minus x1 square minus omega square into a square minus x2 square, which is equal to, if we take omega square common, it will be a square minus x1 square minus a square plus x2 square. So a square will get cancelled. This will be equal to omega square into x2 square minus x1 square. Okay, so that implies omega square is equal to u1 square minus u2 square by x2 square minus x1 square. That implies omega is equal to root over of u1 square minus u2 square by x2 square minus x1 square. Okay, now we know that omega is equal to 2 pi f, which is equal to 2 pi by t. That implies time period is equal to 2 pi by omega. Okay, 2 pi by omega. So here that implies time period will be equal to 2 pi into 1 by omega. Omega is this. 1 by omega will be 2 pi into x2 square minus x1 square by u1 square minus u2 square root over or to the power 1 by 2. That is the time period. 2 pi into x2 square minus x1 square by u1 square minus u2 square, which was asked to prove in the question, and we proved it. Okay, this we have proved. So this is the thing. So the relationship between velocity and position, instantaneous position from the equilibrium or mean position y, this. Okay.